for invitation and good morning, everyone. I would like to present some good practices in our opinion, which we can use to protect groundwater and again and also fresh water mainly in arable land. As everybody knows, we can divide it rural pollution on two groups. First one, and very dangerous, there are point pollutions. I mean here mainly about storage manure directly on the which are putting directly on the ground. It was very surprising for us that nitrogen concentration in outflow water incoming to the groundwater from this small point pollution can be on the level between 300 to 2000 milligrams per liter. It's really strange because nitrogen directive gives permission for 50. So from these small points, this polluted water disappear in the catchment and in the end go somewhere to the freshwater ecosystem. Approximately 50% of mineral fertilizers are also not assimilated during vegetation season by cultivated plants. And also this load of nitrogen goes to the deeper soil and to the groundwater. Another problem in rural catchment are also sometimes illegal discharge from septic tanks from domestic sewage. And these points, as you can see on the right side, are also give bigger load in the catchment scale. It was when we measure the concentration of nitrogen around the points in the catchment, we noticed concentration of nitrogen on the level 500, 700 milligrams per liter. But regular outflow of nitrogen from diffuse pollution are on the level between 100 to 300 pollution. So it's much bigger than it's possible to expect from the bigger scale. Why that's all is so dangerous? Because the outflow of nitrogen from the catchment, from the rural area to freshwater ecosystem, increase eutrophisation. This is environmental point of view. But there are also situations when this nitrogen load can goes to the shallow duck wells, and this water can be used as a drinking water, and that gives the a lot of human threats. For example, methemoglobinemia, which is the most dangerous for children and nursing mothers and infants up to 6 months. That's a high level of nitrogen in the blood. Gives also a lot of birth defects, increase a potential cancer risk, and there is observed also a lot of animal abortion when they use the water polluted by nitrogen. So what we can do? One of the natural process in nitrogen cycle is denitrification. Denitrification works in soil, in sediments, in more or less anaerobic conditions, in case when is available organic carbon for this group of bacteria, for the denitrifying group of bacteria. Naturally, in grassland, the denitrification decrease below 0.6 meter because there are no enough organic available carbon. So in arable land, the value is 0.4, much shallow because the carbon is also used for cultivated plants. On the basis of data of Professor Schipper in New Zealand and Australia, we tried to, 15 years ago, check the biotechnology, which saw the nitrification wall, and we decided to try how it works in our climate, in our climate condition, and in our soils. The biotechnology works as beds somewhere in the soil. When we have the groundwater is strong polluted by nitrogen from different agricultural points. When we want to remove part of these pollutants, it's necessary to add to the soil different kinds of organic carbon. The source of organic carbon can be, for example, pinus sawdust, bile straw, lignite, hard license, and a lot another, which are possible to use in local condition. What is the most important? When we add the carbon to the soil, we create the optimal condition to growth for a group of identifying bacteria. And what is really very necessary to do is creation of optimal pH for this group of bacteria. Regularly in open catchment, natural identification goes in condition rather nearly to acid, 5-6 pH, and it gives the end product of the identification as a N2 and N2O. The effect of this end product of the identification is escaping these gases to atmosphere and possibility to destroy ozone layer in atmosphere. So our aim is to create the beds with pH about 7.5, because when we have the pH up than 7.3, the consortium of group of bacteria create the end product of the nitrification as a N2, and in this way we can close the natural nitrogen cycle to the best product as is possible. Now this is very important to remember about pH of the beds which we create somewhere in the catchment. Here is example how it can look. For example, when we want to protect the place when farmer put the manure somewhere in the catchment directly on the ground, we can build the beds under these places and around these places. And when we have outflow of polluted rainwater which flushing through the storage manure, the water incoming to the beds and activation of this group of identifying bacteria transform the nitrogen to gaseous form, and usually this is N2. Another options is build the barrier as something like a wall. We build this barrier in the catchment near the freshwater ecosystem, and groundwater incoming to the freshwater ecosystem in the catchment. There is not. We create the possibility to flow through this barrier, through these beds, and also the identifying bacteria group transform nitrogen to gaseous form. So there are two main ways for using this biotechnology in the catchment in rural area. in one of our projects, we built the high effective buffer zone when we joined the infiltrating barrier with plant zone with buffer zone. The schematic is in the middle part of the picture. So from this part of the catchment, we observed a lot, usually outflow of nitrate nitrogen on the level between 200-300 milligrams per liter. And this part of Sulejev reservoir at the beginning looks like in this photo on the left. But after our investigation, when we built the infiltrating barrier in the path, on the 1 meter of deep and more or less 1 meter of wave, and we also built the buffer zone with plants. After 1 year, it looks like in the photos in the lower part. So what is the effect? After 1 year of investigation, this barrier in the field, we observe the more than 60% of reduction of nitrate nitrogen. The dark blue bars, there is a concentration of nitrate nitrogen in groundwater after the barrier, but the light blue is before the barrier. So after the barrier, in all of our points, we achieved the nitrate nitrogen level below 50 milligrams per liter. So this is the line, the red line, and this is the nitrogen directive permission for nitrate nitrogen. So now I would like to show you what's how we do it in the next project. So we achieve level of groundwater level in catchment strongly polluted but nitrate nitrogen in much deeper than 1 meter of deepest. So 15 years ago, maybe I should to add, 15 years ago, we built the barrier usually on the 1 meter of deepest. And it was enough to achieve groundwater level for proper working of this barrier whole of the year. But now, last 3-5 years, when we try to find the optimal places for transferring nitrate and nitrogen to gaseous form somewhere in the catchment and to protect groundwater and freshwater ecosystem, usually we find the water much deeper. So in this project, we try to check how it will be work on the 2 meter of deepest, and we build the barrier using the close the organic wood material in some boxes in this modular, and we built the barrier on the end of the field, but before the rivers, and it was on the deepest 2 meter of deep and more or less 1 meter of wave, and we add the organic material to the ground and install the line with piezometers for controlling next 2 years. And we are very, very happy because it also works in the field. So when is no possibility to build the barrier on shallow level, and if it's necessary to go to the deeper line to the groundwater, it also works in the ecosystem, and this group of bacteria can transform the pollutants to the gaseous form. Here is also example from one of the project in the bigger farm. So we built much deeper denitrification beds under the place when the farmer collect the manure from pig's farm, and we built using the brown coal, straw, and pinus sawdust, and we mix this material without any geofibrous boxes, without any modular. Just we put this in the hole in the ground. And also in the next time after the preparing this system, the farmers collect the manure in this place, and during this project we monitoring the effectivity of this barrier with on the deepest meter. So another project, the last one from this group, we decided to build the barrier using the modular boxes, and in this geofibrous we put the organic material, also like straw, pinus sawdust, and brown coal, and this material was putting to the hole in the ground in 3 lines mixed with soil, and the idea was to build the one bed horizontal on a horizontal line, and another one on the vertical wall, because in case if now everything will be cleaned in this part, so on the way, when the polluted water going to the freshwater ecosystem, there is another trap for cleaning the water, and this is the maximum version which we can offer in case when we want to protect the storage manure somewhere in the field. Actually, there is permission for collecting the manure directly on the ground for small and medium in small and medium farms, but it's necessary to remove the manure each 3 years to another place. But during 3 years, the ground around the place when the manure are collected are strongly polluted by nitrogen. So when we install the beds under the place, so it's one of the optimal methods for protecting the groundwater in surrounding area. I would like to add that for all of this biotechnology, we achieved the patents. And so it's very easy to cooperate with companies and employ and this biotechnology somewhere in the catchment when it is necessary. Summarizing, what was very surprising for us, and we are really happy when we achieved a really high efficiency of cleaning the polluted water from mainly usually from storage manure, so even 80% of nitrogen reduction. I was afraid mainly about winter season, because it's completely different climate when in New Zealand, in medium Europe, and so on. So we achieve usually during winter time the highest pollutions, and in this time this group of bacteria under the ground in optimal moisture and optimal availability of organic carbon, pH, and so on. So a few centigrade degree, 8, 6, 8, 9, even 10 sometimes during winter time, it was enough for effective reduction of nitrogen from polluted sewage from the catchment. Big benefits of this biotechnology is also that there is no landscape deformation. This biotechnology we put somewhere in the ground when we achieve the when we find the line of groundwater strongly polluted by nitrogen. So we can use the landscape, everything going under the ground. What is the disadvantages? So hydrological drought. Moisture of these beds is also very important factor for proper works of this biotechnology. So we have to remember about this. So what is the way? We have to build the barrier in deeper way, or closer to freshwater ecosystem, or we can create the runoff from the catchment more much more effective to the beds. So we have to remember that when we add the carbon, create optimal pH condition, we have also remember about moisture conditions. So these beds needs moisture for proper work. One of the possibility to activation of this process is also possibility to adding microbial activator. So we have also done once of this, and it's very important, especially after time of drought. So when we either gives some microbial activator after time of drought in the catchment scale, these beds start work much faster than that's one which weren't activated earlier. So this proposed modular organic plate manure can be alternative environmental friendly solution, especially for small farms in the catchment to protect groundwater against nitrogen pollution, and also in catchment scale as an element of buffer zone, effective buffer zones. And we have to remember that these beds works also very effectively during winter time, when we have not another biotechnology. There are not buffer zones because of the temperature limiting these natural processes. So in my opinion, that's the most important information about this biotechnology. Thank you for attention.